Welcome to the final NLP project presentation. Our topic is noise suppression in songs, and the members are listed below. The contents are: we'll briefly discuss our problem statement and motivation, and how to create dataset and dataset data. And we'll delve deeply and discuss in detail about pitch-to-pitch HDGAN model and one of the interesting observations we found. And we'll finally end with quantitative results. Uh, The main motivation for this is deep learning has achieved a significant improvements in noise suppression for normal charts and conversations. We'll daily use it in Google Meet and so. But when the same algorithms apply to suppression of noise in songs, it will not work because songs contains of high frequency waves audio which combines with the noise. So we thought to use deep learning techniques to create uh, a suppression noise in songs for suppressing noise in songs, which will be useful when recording music and songs with cheaper equipments that tend to introduce noise while recording. And creating the song dataset, we used million songs dataset. We took a part of dataset, 1,000 songs. When I uncompressed, it became 50 gigabytes of data. So due to the memory constraints on our systems, we stuck to 1,000 songs and created the dataset. And the noise dataset is Urban 8K dataset. It has 10 classes from 1 to 10, you can see. And we removed the 10th class. We used only 9 classes, as street music will be similar to our clean song dataset. And we created the noisy songs with the help of clean songs and noise dataset. And yeah, we give the clean song as input, and we expect we give the noisy song as input, and we expect clean song as the output. Yeah, we that will be done through unit architecture, which will be discussed further. And we cannot directly give .mp3 or .wave files. We need to convert into phase spectrograms and amplitude spectrograms, and we need to treat that the phase spectrogram and amplitude spectrograms as images, and we need to correct. Mainly the amplitude spectrogram will be correct. Yeah, our dataset contains of 10,000 samples of 4-second audio clips of amplitude and phase spectrograms. These ultimately resulted in 10 hours of training data and 30 gigabytes of data, and test dataset consists of 1,000 samples of 4-second audio clips, and these created 1 hour of testing data, 200 songs, and 10 gigabytes of data. And pitch-to-pitch HD GAN model. We use pitch-to-pitch GAN model for denoising the songs. That is because usually for song denoising or speech denoising in deep learning, they'll use convolution neural networks called units, which will take input image, which is a noisy song as input, and it reconstructs a clean song without noise. These usually are of resolution 128 cross 128, and they result to 1 second of audio clip. We thought if you can increase the length of the audio clip, suppose say 4 seconds, we can achieve significantly better results. So we use pitch-to-pitch HDGAN model. It can go up to 1024 cross 1024, but we stopped at 512 cross 128, which takes 4-second audio clip as input and gives 4-second clean song without noise. And we found that this has helped in improving the scores, quantitative scores, which will be discussed in the further sections. And one of the interesting observations we found is that if you notice this images in this slide, you can see a huge difference, visual difference between noisy song and clean song. And here you can't see that much difference between noisy song and clean song. Here, that is because here noises there are noisy noises which are of high frequency, and there are some music instruments like guitar and harmonium which creates music at high frequency. So when noise is added to the music of this type which has high frequency, that doesn't change much the output. We found that means we found that even the noisy sound is a little bit clear. That means it's a little bit clear than these songs, which consists of only low frequency instruments like tabla and drum. So this is the one of the peculiar observations we found with respect to the song denoising datasets. These observations are made on our dataset, and mostly we have this type of data as you are seeing in slide, with a huge difference between noisy song and plain song. And evaluation metrics, and most academic papers use PESQ, perceptual evaluation of speech quality, MOS, and HTOA, short time objective measure for time, frequency, weight, and noisy speech for comparing results. And after evaluating our test set with PESQ and HTOA, we got the following scores: 2.7501 per PESQ and HTOA 0.93. And these are considered as good scores. That is because upon referring to the paper listed below, we found that most state-of-the-art speech denoising models have PESQ score between 2.5 and 2.8, and HTOI scores between 0.90 and 0.9. So I think we did a good job on song denoising. Yeah, and these are the references. Thank you, everyone.